Welcome to Calculus AB video for skill number 136. I can find derivatives of constants, polynomial functions, and exponential functions, including higher order derivatives. And featured to the right, we have a Roman Corinthian capital, capital spelled C-A-P-I-T-A-L. The trivia question for today is the spelling of capital with an O has an anagram. With an A there is no anagram, but with an O there is an anagram. So what is the anagram for capital? Alright, so we're going to start our notes on page 136A. And the first thing I wanted to point out was some common forms of derivative notation. So we've learned to use the definition of the derivative, but now we want to talk about notation, and the simplest one I think is y prime. Very commonly you'll see textbooks using dy dx. Less commonly we have df dx, and that just means we want to take the derivative of the function x, or sorry, of the function f. So we could also have dg dx, which would be the derivative of the function g with respect to x. And then this form, d dx, of the function f of x. And this is usually the form that I'll use when I say, hey, I want you to take the derivative of the function f of x. Or maybe I'll write the function in there for you. So below, what I've done is I've written 6 rules, and there's more derivative rules to learn, but these are the 6 we're going to use today. And the first one is that the derivative of a constant is 0. So if I asked you, what is the derivative of 5 with respect to x, your answer would be 0. The next rule is called the power rule, and this rule is the heart of the lesson right here, is understanding this one. So what it says is the derivative of x to the n. What we do is we take the n and we move it down in front, and then we subtract 1 from the n. So if I was asking you what is the derivative of, we'll start easy, the derivative of x to the 5th, we'll say, x to the 5th. We move the 5 down in front, and then we subtract 1 from the 5, so what we have is 5x to the 4th. That's the basic rule, and we're going to apply that a lot in this skill. So the next thing says the derivative of a constant times a function. You can actually just move the constant in front and write the derivative of that function. So if we were to combine these two rules together, we could say, what is the derivative of 3x to the 9th? What we're going to do is the 3 goes in front, and then we just take the derivative of x to the 9th, which is 9x to the 8th, using the power rule, and then we can simplify that as 27x to the 8th. The next piece is when you have two functions being added together, the derivative of that would be the derivative of each independently. So if I ask you what is the derivative of 3x squared plus 7x, we'd take the derivative of the first, which is 6x, and we'd take the derivative of the second, which is 7. So there we go. That's basically that rule. If we wanted to, we could say this is plus or minus, plus or minus. The textbook shows plus or minus. And then the last two rules I put in here because I wanted to talk about them, but in retrospect I think I'm going to come back and visit those two rules later. The basic idea is the derivative of e to the x is actually e to the x, and the derivative of a to the x, if you have a base value of a, then the derivative is a to the x times ln of a. Alright, so this is a cruise through several examples. I kind of showed you on the last page. So the derivative of a constant is 0. If we want to do the derivative of two functions being added to one another, we can take the derivative of each separately. So the derivative of 5x is 5 times 1, because we're applying the power rule, which is 5, and the derivative of 2 we just found out was 0. Extending a bit further, we're going to add three functions together. So we want to take the derivative of 3x squared plus the derivative of 5x plus the derivative of 2. And we find, through a process of using the power rule, that the derivative of 3x squared is 6x, the derivative of 5x is 5, the derivative of 2 is 0. So the derivative of that whole thing is 6x plus 5. And a mondo long one, we can actually just bust it down one at a time. The derivative of 5x to the fourth is 20x to the third. The derivative of 8x to the third is 24x squared. The derivative of negative 12x squared is negative 24x. The derivative of 7x is 7. And the derivative of negative 6 is 0. So there we go. 4 quick examples of the power rule. This should be a pretty straightforward skill. Where it's getting difficult is maybe, just maybe, the next thing, which is higher order derivatives. So let's take a look at that.
This is my new floater by Sherry, and I'm going to show you how it works. First you put it on here, then you press the lock it button, that's that, and then it'll fly up in just a second. See? And then,
Oh no!
So we can also find higher order derivatives. To do this, take the derivative of the derivative as needed. So in this first example, what we're asking for is d2y over dx2. So that's saying take the second derivative of this function. So what we can do is, I wrote out the function rule as negative 16x squared plus 360x plus 150. And then I took the first derivative, hence the f prime, and I applied the power rule, giving me negative 32x plus 360. And then I took the second derivative. So the derivative of negative 32x is negative 32, and the derivative of 360 is 0. So there's your second derivative for that function. In example 6, I just walk us through the first three derivatives of a function. So I wrote down the function, and then I took the derivative. So the first derivative, the 8 comes down in front, and we're 6 times 8, or 48x to the 7th, minus 20x to the 4th, plus 14x. When I take the second derivative, we'll put the 7 in front, and we get 7 times 48, x to the 6th. Put the 4 in front, and we get 4 times 20, x to the 3rd, and the derivative of this is 14. And then one last time for the final third derivative, what we're going to do is we'll bring the 6 down in front, and we get 6 times 336, x to the 5th, minus 240x squared. And you can see that the trend is, with each derivative, the power is decreasing by 1 unit. The 5 to the 4 to the 3 to the 2, or the 2 to the 1 to the 0. Alright, thank you for watching. After this video you should be able to find derivatives of constants, polynomial functions, and higher order derivatives. We'll revisit some of the exponential functions later on in the unit, so those kind of got missed or briefly touched on. The answer to the trivia question, a anagram for the word capital with an O, there's actually two of them. There is optical and there's also topical. Thanks for watching.